Hello everyone, welcome to Abhijeet Codes. I hope you guys are doing absolutely fine. So in this video, we're going to see how to delete a node at a given position in a linked list. Okay, so let's first create a linked list. So let we have got a linked list of size 4 and let the values be 10, 20, 30 and 40. So we will be given the head of a linked list and some position. Okay, the position can vary from 0 and it will be less than equal to n. So 0 position is this first, second, third. So this will be less than equal to n minus 1 only because there is no position after the last element. Okay, here n is the number of elements in the linked list. So how can we approach this solution? So suppose if we have to delete this node present at position 1. So after we delete it, our linked list should look something like this. It will have only 3 elements. Position will be 10, 30 and 40. So how we reach from here to here? Okay. So we see if we need to delete a node, we just need to change this link from here to point it to here. So we just need to change this link only. Okay. This is clear. So suppose this position was at 2. So we needed to change this link from 20 to 30. We need to change this link from 20 to 40. Okay. So it is clear that we need to be at an element just below a position. Okay. If our position is 2, we need to reach or we need to get hold of this 20. Okay. So for this we will take some current variable. Initially it will be pointing to head. Okay, and we will move this current till a position less than our given position. Okay, then we will change the links. So we need to keep in mind that if the given position is 0 only. Okay, so what will happen in this case? So in this case our head will become the next element in the list, and in this case we don't require current. Also, it is possible that our given linked list can be empty or it has only one element. So first we'll check condition. If head equals null. If this is true, we simply need to return null, because if there are no elements, we can't delete any of them. Okay, so this might be very clear. Then what we'll do, if there is at least one element, then what we need to do? So suppose if we need to delete this jth element, so we need to take care of this also explicitly. So we will do if our position is equal to 0, that means we need to delete the first element of the linked list. So to delete it, we simply need to make this heads next equal to null. Okay, so we will do head next equal to null, and our second element will become the head. So for this we will write, so first we need to save the head next, because if we don't save it we will lose access to it. So we will first do, let's suppose list node, we will name it new head. Okay, new head equals old head arrow next. So we will save this, then we will do head arrow next equals null, Then we will delete this head. In C++ and in Java you don't need to delete this, and then we will simply return our new head. Okay, so we have handled the cases for no elements and the position 0, and for the rest of the cases we will write a program. Okay, so our list node will start from current. So initially it will be head, then now we need to move this current. Okay, so this current we need to move one position behind the given position. Okay, so we will write a for loop for this. So we will write for int I equals 1, I less than position and I plus plus, and at each iteration what we'll do, we'll do current equals current arrow next. So our current will keep on moving one step at a time until we reach just behind the given position. Okay, so if our position was, let's say, 2, then our current will move first time here, then it will stop. Okay, because initially the value of int I is 1, 1 is less than 2. Okay, condition satisfied, so current will move, so current will move from head to this one index element. Next I will become 2, and 2 is less than 2 is false, so we'll come out of this loop. Okay, now once we reach our current reach here. Okay, if our current is reaching here, we need to change this link. Okay, so first we will store the next element of current. So we will do list node, let's call it temp equals current arrow next. So we have now stored this next, currents next we have now stored. So it is also possible that this current arrow next can be null, because suppose if we have to delete this last element, then its next will be null. So we need to check this condition also. So we will do if current arrow next is not equals null, or we can write if temp is not equals to null. Okay, both will be fine. So if this is not null, then only we need to make some changes. Okay, so if current next is not null, what we'll do, we will do current next equal, so if this is not null, okay, then its next will be existing, and if it is null, then its next will not be existing. So we'll, what we'll do, if it is not null, we will do current equals temp next. That means we are doing currents next like this, so this will be linking to this 40, and if it was a null, it will link to null only. Okay, now what we'll do, we need to make temp next null and then delete null. Okay, we'll do temp next equals null, then we'll delete this temp because this temp is of no use to now. If this was null, we simply need to do currents next, sorry, it will be current next here. Okay, because we are changing the next of current, not current, so current next will be temp next, and then temp next will be null, then we delete temp. So if current next was null, that means it was the last element. So in this case we will do current next equals null. Okay, and we don't need to delete temp because temp is already null. Okay, and we'll simply return head, and we'll close this. So let's see how to code it in our compile. It will be exactly same because I have written almost the same code. So there is a problem on HackerRank, it is delete a node. So in this we are given the head of a linked list and the position, and we need to return the head of the linked list after deleting the node at given position. So what we have told, we will check first if a list equals null. So if it is null, we will do simply return null. Okay, next what we need to do, we will check if position equals 0 or not. So if position is 0, it means we need to read the first element. So we'll do singly list node, and we'll make a new head equals a list next. Okay, then we'll do a list next equals null, then we will delete this a list, and we'll return our new head. Okay, so we handled the both cases. Now we'll make singly linked list node current equals a list, that is head here. Then we will traverse writing a for loop int I equals 1, I less than position I plus plus, current equals current arrow next. So it's typo. Then we have reached the node before the last node. So we will save the next node in temp equals current arrow next. If temp is not null, temp is not null, what we'll do? We will do current next equals temp next. Okay, then we'll do temp next equals null, it will be capital null here, and we'll do delete temp. Okay, so we see that if temp is current dot next and it is already null, that means we don't need this current arrow next equals null, so we'll comment it out. Okay, now let's try to run it. So we see sample data are passing, and if we submit it, we will see all the data are passing. Now let's discuss the time complexity. For this solution, the time complexity will be big of n, because we are in the worst case, we need to traverse the whole linked list. Okay, and the space complexity will be big of 1, because we are just using few pointers. So I hope you like this video, and if you like this video, please subscribe the channel and share it with your friends. And if you have any questions or doubts related to this problem, please do mention them in the comments. I will be more than happy to reply to your comments. Okay, thank you, and see you in the next video.